Hello, this is the first video for Chapter 4. This video I'm going to talk about the material. It's roughly sections 4.1 through 4.4 in the textbook. Basically everything that's going to be covering the replacement rules. So I'm going to introduce the 6 replacement rules for Chapter 4 and do some examples. Future videos or subsequent videos will do the topics of indirect proof and tautologies. But for now, just the replacement rules. Now, with the replacement rules, this chapter is basically a continuation of Chapter 3. And Chapter 3, which was on the proof method, there were 2 main things going on. One was the inference rules. There were 6 inference rules in the regular material and 2 additional rules in the optional material. And conditional proof. Chapter 4, we're getting analog, some more stuff that's similar to those things. Instead of inference rules, we'll be getting replacement rules, which are similar to inference rules in a lot of ways. We'll also be doing introducing indirect proof, which is similar to conditional proof in a lot of ways. The topic of tautologies doesn't really have an analog in Chapter 3. But the first topic is replacement rules. So let's go ahead and get started. I'm going to introduce 3 replacement rules right now. Now, the first thing you can see, so this is the first replacement rule called conditional exchange. We'll abbreviate that CE. And the first thing you'll notice is that the rule is expressed differently. Instead of there being some statements and then a line and then another statement arranged vertically, here there's 2 statements arranged horizontally, separated by this quadruple dot. What this means is, or the way to think about this, is what this rule is saying you can do is anytime you have a statement of this form, you can swap it for a statement of this form. So basically this rule says if you have a conditional, you can swap that for a disjunction if you negate the first component. So if phi then psi can be swapped for if not, not phi or psi. Now, the replacement rules, one of the differences is that they can work in both directions. So not only is it the case that if I have something like this, a conditional, I can turn that into a disjunction if I negate the first component. This rule also says that I can go the other direction. If I have a disjunction, I can turn that into a conditional if I negate the first component. Okay, so the replacement rules work in both directions, whereas with the inference rules, they only worked in one direction. The visual schematic was arranged vertically and you could only go from top to bottom. Okay, so that's conditional exchange. The next rule is double negation. This is also, well, this is pretty intuitive. This just says that you can swap phi for not phi. Of course, phi can be any statement. So basically this is saying you can add or subtract tildes as long as you do it in pairs. So if I have phi, I can add 2 tildes and make it not phi. Or if you have not phi, you can take 2 tildes off and turn it into phi. Commutation. There's 2 versions of this. There's a version that applies to disjunctions and a version that applies to conjunctions. And what this basically says is you can swap the order of the disjuncts in a disjunction. So if I have phi or psi, but I want to swap the order, I'd rather have psi or phi, I can do that. I can just replace this with this. And I can do the same thing with conjunctions. If I have phi and psi, I can replace that with psi and phi. So those are the first 3 replacement rules. Now I want to, before we do some examples, I just want to talk a little bit about the differences between the inference rules and replacement rules. One big difference is that inference rules cannot be used on parts of a line. Recall from Chapter 3, it had to be an entire line that you use the inference rules on. Replacement rules can be used on a part of a line. So for instance, look at this sort of imaginary part in a proof. We've got lines x, y, and z. On line x, there's this conditional, if A, then if B, then C. What you could do is on the next line, you could turn just this interior conditional, just the one that is inside here, this consequent, turn that into a wedge. So horseshoe becomes a wedge. You have to negate the first component. So remember what conditional exchange says. If you have a conditional, you can turn that into a disjunction, but you have to negate the first component when you do it. So conditional exchange was used only on this part of the line. The rest of the line stays the same. You're just sort of keeping the same line, but you're just using the rule on part of it. Now you can also use the rule on a whole line, of course. So this entire line here is a conditional. I could turn this whole thing into a disjunction and negate the first component. That's fine. Okay, so you can use the replacement rules on parts of a line as well as on an entire line. The next, well, so actually this isn't next yet. I'm just sort of re-emphasizing. So here it was used on part of a line, the transition from line X to line Y. Then on the next one is the transition from Y to Z. It was used on an entire line. Okay, the other thing, I've already mentioned this, but I'll say it again. If we go back here, what I did is going from X to Z, I was changing conjunctions into disjunctions. But these will work either direction. I can also use it to change disjunctions into conjunctions. So I could change this, not A or, not B or C. I can change this wedge into a horseshoe. I have to negate the first component when I do that. And then on the transition going to line Z, I could change this disjunction into a conditional. I have to negate the first component when I do that. Okay, so that's the basic idea behind the inference rules and replacement rules, the difference between the two. Okay, so let's do an example. Now the first thing that you should notice is that when we look at this proof, there's a lot of ways we could approach this proof. We've got a lot of rules that we can use. We have inference rules, replacement rules, we have conditional proof. There's a lot of things at our disposal. One of those things is a conditional proof. And I'm looking here, I'm saying, okay, we're trying to get not R. This is R. I know if I can get R, then I can just do double negation to get not R. So how can I get R? Well, obviously this is the consequent of this conditional. If I could get this antecedent, I could get R by modus ponens. So how can I try to get this antecedent? Well, you'll see, first thing I'm going to do is I'm going to turn, and you'll see why later, I'm going to turn this into a conditional. So this is a disjunction. I'm going to put this line down here on line 4, except I'm going to turn the wedge into a horseshoe and I negate the first component. So I've turned the disjunction into a conjunction. So that's line 1 conditional exchange. Now I'm going to go ahead and do a conditional proof. Now what conditional do I want? Well, I'm looking at this and I'm saying, look, if I had if A, then D and E, then I could just double negate the A, commute the D and E, and then I'd have this antecedent. So that's what I'm going to do. So I'm going to assume A. If that didn't make sense, wait till the end and then you'll see why I did what I did. Okay. Assume A. Now my goal is going to be to derive D and E. And you can see that's going to be really easy. Because I have A, I could do modus ponens to get not C on lines 2 and 5. Now that I have not C, I can do modus ponens on 4 and 6 to get D and E. And I'll go ahead and close that there. So that now I have if A, then D and E. Now you can see why was it that I wanted this conditional? Well, look, I wanted it because I can turn this into this antecedent with the replacement rules. I have to turn A into not A, and I have to turn D and E into E and D with commutation, but I can do both of those things. So the first thing I'm going to do is do double negation on A to make it not A. Then I'm going to commute D and E into E and D. Now, this is that antecedent, so I can do modus ponens to get R. And then finally, double negation to get not R. All right, let's do another proof. We look at this strategically, there's two big things we could do. We could just try to derive something using only the rules, the inference rules and replacement rules and conditional proof. Or just the inference and replacement rules. I'm going to go ahead and use conditional proof on this because what I'm trying to, the conclusion is a conditional. Before I do that, though, one thing I'm going to do is I'm going to turn both of these disjunctions into conjunctions. So I'm going to turn line 1, instead of A or B, I'll get if not A, then B. That's by conditional exchange on 1. Then I'm going to get, oh no, I'm not going to turn 2 into a conditional. I'm just going to commute. Instead of C or D, I'm going to get D or C. Okay. Now, and the reason, well, you'll see. Now I'm going to go ahead and do my conditional proof. I'm going to assume not A and try to get C, or not C, but it doesn't matter. Either of those is fine. If it's not C, great. If it's C, then I'll just change it into not C later with double negation. Oh, wait. Haha, sorry. Okay, now I'm going to turn this into the conditional. If not D, then C. Conditional exchange on 5. Okay, now here's my assumption for conditional proof. I'm going to assume not A. Now my goal is just to get C. Or not C, it doesn't matter. But now that I've got not A, I can get B by modus ponens. Now that I've got B, I can get not D. And with not D, I can get C by modus ponens. So that's why I turned all of these things into, I turned this into this conditional, and I turned that eventually into that conditional, is because I knew that once I would get not A, the way I could get C was by doing this chain of modus ponens. How did I know that? Because I just kind of eyeballed it. This is something that will happen once you get sort of good at doing proofs, is you'll be able to look at things and just see them. Okay, so I'm going to go ahead and close this off now. And when I do, obviously, I'm going to get a conditional. Antecedent is this, consequent is that. If not A, then C. And that's by lines 7 through 11, conditional proof. I'm not quite done yet because I need, instead of C, I need it to be not C. So I'm just going to do double negation on 12 to turn that into if not A, then not C. Okay, let's get the last 3 replacement rules. First up is De Morgan's. This is extremely useful rule. Do lots of proofs that use De Morgan's. Get really good at it. It'll make your life way easier if you're proficient at this. What De Morgan says is that you can turn, let's look at the top version first. You can turn a negated disjunction, so this is a disjunction and the whole disjunction is negated. We can turn a negated disjunction into a conjunction of the negated disjuncts. So let me walk through that again. You can take something like this, a negated disjunction, and what can you do with it? Well, you turn the wedge into a dot. I get rid of the exterior tilde. This whole thing isn't negated anymore, right? This whole disjunction is, but the conjunction isn't negated, okay? So I turn the wedge into a dot, I get rid of this external negation, but I have to negate both of these components. Phi becomes not phi, psi becomes not psi. Okay? You can also go the other way. If I have a conjunction, I can turn that into a negated disjunction. So dot becomes a wedge, negate the whole thing, so put parentheses around the disjunction, negate it, and both of these components have to get negated. Not phi becomes phi, not psi becomes psi. Okay? This, and there's also a version where you can turn a negated conjunction into a disjunction of the negated conjuncts. So here's a negated conjunction, dot becomes wedge, get rid of the external negation. This whole statement is no longer negated, but each of the components is negated. Instead of phi, it's not phi. Instead of psi, it's not psi. Okay, we'll see a lot of examples of this. Get used to this rule. Next up is contraposition. You might have noticed that with the rule of commutation, we could commute a conjunction, so we could swap the order of conjuncts. We could commute a disjunction that lets us swap the order of disjuncts, but there was not a rule for conditional. You can't do commutation on a conditional. Why? I mean, I could ask you the question why, and your first thought should be, well, probably because it's not truth preserving, and you'd be right. If you just swapped the order of the antecedent and consequent in a conditional, that would not be truth preserving. But you can swap the order of the antecedent and consequent if you negate both of them when you do it. So you can go from if not phi, then psi, to if not psi, then not phi. So that's what this rule says. You can swap the order of the antecedent and consequent in a conditional as long as you negate both of the components when you do that. Finally, association. There's a version for disjunctions and a version for conjunctions. Let's look at disjunctions first. This says that if you have, and if you look at this, it's essentially 3 disjuncts in a row, phi or psi, and then that whole disjunction, or chi. And this middle disjunct is grouped with the first one, and the third one is kind of by itself. Okay? What association says is if you have that, 3 disjuncts, the middle one is grouped with the first, you can instead take this middle one and group it with the last. Okay? So instead of phi being the second disjunct of this disjunction, it becomes the first disjunct of this one. Or you can also just think of this as taking these parentheses and just sliding them over 2 characters. Right? So you're moving this to there and moving this one over to there. And you can go either direction. I can slide these parentheses to the left or to the right. So I can move from this to this, or I can move from this to this. And then there's a version for conjunctions as well. If I have 3 conjuncts, the first 2 are grouped, I can instead take the middle one and group it with the third one so that the last 2 are grouped. Okay, let's do a proof. I'm looking at this and I'm saying, look, this is a negated conjunction. One way I could get this is if I have a disjunction, because De Morgan's lets me turn a disjunction into a negated conjunction. Well, what would that disjunction have to be? Well, it would be a disjunction where the dot is a wedge. That's why it's a disjunction. The whole thing isn't negated, but each of these components is negated. So I'd have an E or D. That would be what that disjunction would be. So if I could get E or D, I could just do De Morgan's to get this. Well, look, I can get E or D. I just use DI on premise 1. So here's E or D. I've got DI on premise 1. I've got a statement. And I just disjoined any other statement I want. So I've got E or D. Now I'm going to do De Morgan's on this. And this is only a 2-step proof right there. Now, just to show you what I did here, so this is De Morgan's, and this is the version we're using. We're turning, in this case, we're turning a disjunction into a negated conjunction. So we're turning this into that. So let's look at this carefully. Here is a disjunction. Okay, it's just statement, wedge, statement, statement, wedge, statement. This is a negated conjunction. The whole thing is negated, and what's negated is this conjunction here. The other difference is that each component has to be negated, right? So E, I made that not E. D, I made that not D. The reason this can be confusing is in the written schematic, it was the disjunction where the components had the tildes. And in the negated conjunction, they didn't have tildes. But remember, you can negate a statement by adding or subtracting a tilde. Here, it was negated by subtracting one. Not phi became phi. Here I negated by adding one. E became not E. D became not D. Okay? But this is exactly this move right here. Okay, so that's that proof. It's actually only 2 steps. Let's do another proof. So if you're looking at this, you might say, hey, look it. Oh, by the way, I should say something before we start. Here I've got the conclusion after the first premise instead of after the second premise. Normally you shouldn't do that. Conclusion always goes after the last premise. I couldn't do that here because on the slide both of these statements are too big, so I just fudged it and put it up here. Don't do that in general yourself. Okay, I'm just doing that because I have to. All right, I'm looking at this and saying, okay, here's A, here's this, I want to derive that. I remembered, oh, this is this antecedent here that I'm trying to, of the conditional I'm trying to derive, is a negated conjunction. And here's one of the negated conjuncts right here. So I can do the same trick I did last time. So I'm thinking, I know, maybe I can get this antecedent, and then maybe once I get the antecedent, I'll figure out how to put this consequent on. So I'm going to go A or B, that's by DI on line 1, and then do De Morgan's on that to get not A and not B. This is exactly the same thing we did in the previous proof. I had a statement, I disjoined something to it, and then did De Morgan's so that I could get a negated conjunction. Now my question is, how can I turn this into this? I've got the antecedent, is there a way I could get the consequent? And you can pause this if you want and work on different ways, but there really isn't any way to do that. There's no way. If I just do DI, I could go DI and I could say or not P or not P, and then try to change that into a conditional, but when I do, this tilde comes off, and so I don't have this antecedent anymore. So that won't work. So I have to go back to the drawing board. And when I do go back to the drawing board, I notice that, this is just the contraposition of that. If I do contraposition on this, remember I can swap the order of antecedent and consequent in a conditional, but when you do, you have to negate both of them. So this, not, if P then not P, would become the consequent and get negated, and I can negate that by taking this tilde off, and so that would just be if P then not P. This would become the antecedent, and this would be negated. I would put a tilde out here. So let's go ahead and do that. So it's still a conditional. This becomes the antecedent and gets negated. This becomes the consequent and gets negated by taking one tilde off. Okay, so far so good. This is the right antecedent. This consequent isn't right though. But notice if I just do conditional exchange on this, horseshoe becomes a wedge, negate the first component. Now this is the same. And the proof is done. Okay, well that's it for this first video for chapter 4. Next up will be a video explaining indirect proof.